Hello. Camera. There we go. All right. Good. Hi, everybody. Good morning, good afternoon, good evening. Hello. This is my first time doing a live stream back at home, for a couple of days. How are you this evening, this afternoon, this morning? Wow. It's going to be a busy few weeks, months even. Like basically from here to the end of May is going to be ridiculous. So we're going to try and do as many of these live streams and videos as possible. But just bear in mind, on Sunday, I fly to Europe for Kotlin Conf and for the Utrecht Jug, and then and then I go to Paris, France, for not Texas, for Devox France, and then I come home for a few days, then I turn right back around like 3 days later and head to Bombay and Bangalore, India. And then I come back here for a few days, and I turn right back around and I go to Europe for 3 weeks in a row for Devox UK and Devox Greece and Spring IO. Okay, so if you're in any of these places, I want to hang out. Say hi. Come say hi. Let's talk software. Yeah, come. Yeah, Simon, it's gonna be fine. Don't worry. I mean, you've probably already understood all this stuff, but you can meet cool people. You know who's gonna be there? Trisha Gee. It's a double header. Trisha Gee is gonna be speaking that night. So even if you've already seen my nonsense, and I'm sorry, come to see her. She's amazing. Legend. So I can't wait to be there. That'll be the Utrecht Jug. I think that's on the 11th of this month. So is that right? 4 days? Yeah, it's all going to come together here pretty quickly. And yeah, it'll be fine. Just come on. It'll be great. But also, I'm going to try and do these live streams, Wi-Fi and time permitting. Right? There's a lot of bouncing around hotels and all that. We'll see. We'll see what happens. I'm hopeful, but cautious. Today, my friends, we're going to try and make RabbitMQ streams work. You're reading 2 of her books. Yes. She's a legend. One of those books, the JetBrains IntelliJ book that she wrote, she co-wrote with one of her JetBrains alumnus or ex-colleagues, is using, I'm very proud of this, I'm super proud of this, it's using the Spring Batch powered GitHub Actions pipeline that I built to self-publish my book, right? So it's using ASCII Doctor. So 99% of the code in there is, of course, Dan Allen and the ASCII Doctor team, right? I mean, obviously, they are legendaries, and they have made the world a better place for their ceaseless contributions to open source, right? I don't know if you've all tried ASCII Doctor. It's one of those things where really there's just 1 or 2 people working tirelessly to make it a thing for all of us. So if you see Mojave Linux, Dan Allen on Twitter, say hi, say thank you. Just that's a person that, he should be making millions, but he's probably not. He's just such an amazing human being. That pipeline uses all of Dan's hard work, and I added some code myself, and that code took me a fair while. You're reading. The 97 Things one is great too. I have a chapter in there, or not a chapter, an article in there. That's a great book. She's an amazing editor. Okay. Anyway, so this is gonna be a fun few months, my friends. And then you know what happens at the end of May? My daughter graduates high school. She's going to graduate high school. That means that she's officially going to college, which is, crazy to think about. And so we're, it's just going to be a roller coaster, my friends. It's going to be nuts. In the summer, I have some business in Asia, but basically we're going on vacation, right? It's the girls and I are going to go to Asia. So I'll be doing live streams from there. So, find me. I expect to be in Korea, Singapore, and Malaysia at the very least, right? So maybe we'll do a meetup there or something, or we'll find out. But if you're watching this from there, please don't hesitate to join me. Oh, by the way, if you're in Asia and you speak Chinese, My buddy's book. I wrote the author. I wrote the forward for my. I have a friend from. I met him when he worked at Alibaba like 10 years ago, right? And his name is Shui Feng, and this book is, don't ask me what it says. I know the word spring. I can tell you what that means, but basically, yeah, you can buy this book. It's in Chinese, obviously. So if you don't speak Chinese, then sorry, But yeah, there's that new spring book. I don't know what it says. I don't know if it's good. I know he's great, right? I know his technical prowess, his technical chops are top shelf, top tier, And I've worked with him before. I helped him at Alibaba years ago. So I remember I turned up. I was looking for examples of people using the cloud back in 2012, right? And I was looking for something to sort of demonstrate the potential offered by a optimized path to production like Cloud Foundry. So I started shaking the cobwebs to see what would shake back, and I found a company that was using not only cloud at amazing scale, cloud computing. This is remember 2012, cloud computing still, more nebulous. So I was looking for somebody who's using cloud computing. I got back somebody who's not only using cloud computing, but also Spring, and also at unparalleled scale, right? Spring was everywhere. It is super entrenched, and it's being used in one of the largest websites on the planet, and that was Alibaba, right? Actually, that's an organization which has several different websites. And my friend here, he worked there at the time, and I took a train from Shanghai to Hangzhou. So Hangzhou is couple hours train, maybe 3 hours, I guess. It's not a very long ride at all, and the trains are super comfortable and fast and all that. So it's a short ride from Shanghai to Hangzhou, and this guy he escorted me from Shanghai to Hangzhou, and then made sure I didn't get completely lost or starve because I couldn't read the menus, so. Yeah, let's see here. Yeah, the kids do grow up so. Yeah, they grow up so. She's grown up so fast, and she's she's still a little kid. I mean, she's still always going to be my little kid. But wow, she's going to college, and it's I don't. This is one roller coaster. I'm kind of sad. Like, I don't love roller coasters usually, but this has been one that I'm going to be very sad when it's gone, like I can't believe it. Let me see. Oh yeah, how does the Ali Cloud variant stack up versus AWS GCP Azure nowadays for EU USA customers? So few people even know it exists. Yeah, Ali Cloud, Aliyun. It's called Aliyun in China. Aliyun is it's a subset. Right? Do you know they actually have a Microsoft Azure in China, right? And so think about that. Like, think about the opposite, right? We, as a Western entity, and if you want to have a cloud presence in China, you can't really do the same thing, right? There's a lot of reasons, but basically, like, when you use Microsoft Azure in China, it's like a white label distribution of Microsoft Azure that's installed in Chinese data centers and managed on Chinese soil, and so it's not connected in any other way to the rest of the cloud, right? And I think maybe the same is true in the reverse. Like, if you're using Aliyun in the West, there's still an amazing complement of services, but I noticed that they definitely debut things first in China. It doesn't proliferate to every other data center out in the world immediately, because it takes time, right? I think they want to validate that it'll work at scale and so on. So what better proving ground than China, right? One of the biggest markets on the planet, the biggest market on the planet, really. So yeah, it's not always on par. They're not exactly the same, but you can count on the idea that if it's good enough, it'll eventually percolate and become available in the rest of the world. And the stack is pretty good. I found it to be very, how AWS is kind of like everything. It's everything, right? Everything. And there's a million different checkboxes, a million different things you can do. I don't even know what half of them do anymore, right? I've lost the ability to keep track. But if you go to Microsoft Azure, it's starting to get to the point where it's like, okay, there's definitely everything. Every use case I might have, there's a checkbox or a button I can press on Microsoft Azure to get me to a solution for that use case faster, right? It's getting to the point where it's like AWS. Whereas Google Cloud, and I'll even feel very sort of, what's that word? Manicured and curated. There you go. It's very much like it's a suite of pretty well put together integrated things. And if you have a problem for which those things are solutions, they work particularly well. But there's no like, if you have a solution that they didn't envisage, then you just have to start from zero. Basically, you start from the VM at that level. And I quite like it. It's approachable. You can actually kind of survey the platform and get most of the things you want pretty quickly, and it's fine. I like it. We also have a Spring Cloud for Alibaba, right? We have a distribution. It's maintained by our friends over at Alibaba, of course, but we have a Spring Cloud distribution, just like we have Spring Cloud for Microsoft Azure, Spring Cloud for Google GCP or Google Cloud. I think they changed the name, didn't they? Hey, Spencer, I saw you there, buddy. Did they change the name to like Spring Framework for Google Cloud or something like that? I think they changed the name. I could be wrong. Maybe I hallucinated that. And then also there's a Spring Cloud for AWS, which is, and these are all maintained by people that know Spring. It's amazing. And they're also save for Spring Cloud for AWS. They're also maintained by people who work at the respective company. So they're all very good. The Alibaba one is very good. I even did a Spring Tips video. It's pretty a few years old at this point, but you can see it. There's a Spring Tips video on using Spring Cloud for Alibaba. Okay, so anyway, today, friends, hey John, do you know of any plans of patching older versions of Spring Boot to allow for Snake YAML 2.0, or are custom patches going to be required on an application by application basis? That's a great question, for which I don't have an answer. Do I know of any plans to allow for Snake YAML 2.0? Really good. Let me see. Hold on one sec. I can always ask. I can't do much, friends, but I can at least ask for you. We started the stream today. I've been up for an hour and a half, and I wanted to talk about RabbitMQ streams, right? I haven't done this, and I wanted to hello everybody. By the way, hello, Assad. Hello, welcome. Thank you. Let's see. So. Let's see here. Boot team won't upgrade a major version. Oh, yeah, that's true. That's true. That's probably the answer then. Yeah, if it's 2.0 versus 1.0, then yeah, that's not going to break in the 2.89 version if they ever did one, or 2.8 or whatever. That's not going to happen. That's a good point. Thank you, Spencer. See, you saved me and them some time. Okay, so today, friends, we're going to look at RabbitMQ streams, and I don't know what I'm doing here. So I kind of got it to work off stream, with the help of the amazing, the ceaselessly, endlessly patient and kind Spring integration lead, Artem Bilan, who, hasn't blocked me on Slack yet, which is I don't know why. I mean, he's just really, 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 really nice, and so I was lost. I was in a soup of confusion this morning, and he was more than kind to help me. So we're gonna work through that haze again while it's still top of mind today. And what I want to show you is RabbitMQ streams from the context or the perspective of Spring integration. Okay. And what we talked about yesterday was we looked at RabbitMQ yesterday, right? And actually, let's review. Let me get my screen going here. Entire screen. Let me close Slack. I'm going to close IntelliJ. Now keep that. Share. Sweet nectar. Okay, so we've got our little browser going. Where's my code? I refactored the code that we did yesterday as well. Not too much. It's not like it's JBoss limitations. JBoss AS. You have JBoss limitations causing the application to be stuck on Spring Boot 2.3, which is old. Oh, well, you know. I should really try, Spring Boot in the context of like an application server, like a EE application server. I haven't done that in, years. Oh, and that's a good point. Like, I wonder what Spring Boot 3, which is now Jakarta EE, I wonder how well that's going to play in some of these application servers, which of course are much slower to update to new versions of EE, because that's a whole feature for them. It's a whole new release. I wonder if that would work. Like, I don't know. I have no idea. What does it look like to run a Spring Boot app using Jakarta EE in whatever the current version of Wildfly is today? I have literally no idea. I have no idea. I'm just guessing. Okay. So here's the code from yesterday. Can you all see that? Let me make that font a wee bit larger. I refactored it a little bit. Okay, so let's talk about what we did here yesterday. First things first, we talked about how you can establish, AMQP. I have a client using an old WebLogic version. So to answer your question, badly. Yeah, it's probably true. Yeah. Yesterday we talked about how AMQP defines the ability to create the infrastructure, the middleware, the machinery of your messaging system through the network protocol itself. So it's a bit like being able to provision HTTP services or servers using HTTP, the protocol, right? It's very weird, but it's magical because it means that your program is self-reliant. You can just define and then use everything you need from the same protocol. You don't have to have somebody log in and drag and drool and click some buttons or whatever to provision a broker and exchange and queue and all that. You can do that one of two ways. One is you can define beans of type queue, exchange, and binding, which is and then just have @bean methods, and those will get registered for you automatically. You can also programmatically do that by injecting the AMQP admin. Well, yesterday I had to create 2 different queues and beans and all that. So last night I rewrote the code to just loop over the different names, and then for each name define with the AMQP admin and the name to define a queue, an exchange, and a binding, so that they all are all connected to each other. Okay, so I just did that. So when the application starts up, I define 2 queues and exchanges which are bound together through a binding, and there's a routing key. Okay, and then we also have like basic RabbitMQ stuff. So here's RabbitMQ. I'm using Spring for RabbitMQ. Or Spring RabbitMQ or Spring AMQP or whatever the project is called these days. And it's just as low level as it gets, right? So I'm using this Spring AMQP template. I'm turning my payload, which is this map. I've got this little static method here to create a map with a string, with a message and a string value for the value. I'm using Jackson to turn that into a JSON message. And I'm creating a message. This is using Spring AMQP's message builder, right? Not Spring integration or Spring messaging. It's message builder with body, setting the content type to be application JSON. And I'm sending the message, this thing right here, to this queue with this routing key. And here's the message. Okay, great. And then on the consumer side, I'm using a RabbitMQ listener to then consume that message. And I'm teasing out, rather than using the message envelope object itself, I'm teasing out the headers and the payload. Okay, so I'm saying give me the headers, which is just a map of string, right? And I'm also getting the payload itself. which has a byte array as a body, right? Bytes. And then I'm just using Jackson to turn that back into the same map. And then I've got this method here where I'm just dumping the payload and the headers, okay? So, and I'm using that for both the integration and the RabbitMQ code. Okay, great. So that's basic Spring for AMQP. Slightly different from what we looked at yesterday. I think we did indeed cover all this stuff at some point or another, but by the time we were finished, the code was in such a state that the Spring for AMQP stuff was erased or overwritten by the Spring integration stuff. So now I've got them both living in tandem in the same code base. And then we introduced Spring integration, right, which is actually what we're here to talk about. And we have an inbound Rabbit flow where we're saying, okay, from the AMQP inbound adapter for this queue, expect, oh, you don't have to do this. I gotta remember to like stop doing that. It's my habit. From the inbound adapter, expect new messages, and also you don't need to do this. Okay. So from the inbound adapter, I just get the message and I dump the results using that same dump method that we saw earlier. Fine, easy enough to understand. I have a channel here, and for the outbound, I'm saying whenever a message comes in from this channel, send it out via the outbound adapter to this integration requests queue name, right? And so, and then use this routing key and set, etc. So notice that I don't have to deal with content negotiation. I don't have to do. Ooh, somebody's calling me at the least opportune time. I don't have to manage or negotiate any of that stuff. It's just handled for me. So I just set the routing key. I set the exchange to which the message will go. By the way, that's the other thing we established yesterday with RabbitMQ. You have an exchange. An exchange can route the message to a queue. So there's a bit of indirection between the producer and the consumer. They're not sharing the same exact logical thing. They're different constructs, and you can interpose like filters, if you will. You can interpose routing in between the exchange and the queue, so that while the connection is basically point to point today, it might actually have multiple other stops on the journey tomorrow, and the consumer and the producer need not know. Okay, so very, very convenient. Here's the outbound one. Like I said, it's just sending the message out. So I suppose logically this is the outbound and that's the inbound. So outbound would come first because we're sending the message out, and then it's coming right back around. After visiting the broker, it's coming back around here, and we're consuming the message and dumping out the results. And so when the application starts up, I get a hold of the channel, and I send a Spring messaging message, not a AMQP message, with a payload, and the payload is just a map, and so on. So let's just, so this, in order to make that work, I'm using Docker Compose. Don't need that. And I've got the username and password set to user and password. In the properties, I've got, I've specified Spring Boot auto config for the username and password. Okay, by default, it's connecting to localhost, etc. So this works fine. This is like what we talked about yesterday. And as you can imagine, all it does is it sends out two messages and it prints out, when I get the message back, it's a map that says hello integration and hello, what was the other one? Basics. Okay, so good. We're on the same page. Nothing conceptually new here compared to what we looked at yesterday, but I just wanted to kind of like refresh ourselves on that. Okay, basics, get status. Good. Now, this is a message queue. RabbitMQ is a message queue by default, and it's great for transactional kind of messaging, right? If, like, think of JMS, but much better and much more flexible and more in offering more indirection, right? Remember, economics informs architecture, and optionality informs architecture. What are the things you want options with? With messaging, the whole point is to introduce or to reduce coupling, right? You want to introduce decoupling or reduce coupling between systems. And so the idea that you have a Java-only API that is sensitive to to differences in the Java API between the client and the server, that only has one logical connection called a JavaX JMS destination, is terabad, right? It's the opposite of what we're trying to do with messaging. You might as well use RPC. It's almost that useless, right? And RPC is never the right answer. So, well, almost never, unless you're using modern, like non-blocking reactive messaging style RPC, like RSocket. Okay, so this is, I like RabbitMQ. It gives us all this stuff. Oops, I'm helping. Yes. Hold on. Okay, so my friend just arrived from Singapore, like I said, and we're going to meet up later. And he just sent me a very important question, which is, do you usually tip Uber drivers? And the answer in the United States is absolutely. Tip everybody that can get tipped, because people don't get paid well here. It's not great. It's like, it's not a, we're not doing the best that we could for each other here. Okay. Oh, whoops. Okay, so okay, good. So we got Spring, we got this. RabbitMQ is a broker. Like I said, it's good for transactional messaging, and it's interesting when you send a message. That message is gone. If you send a message and then you consume the message and you've acknowledged the message. And by the way, there are gradients here. By default, I'm taking the message, and as soon as the message is delivered, as long as I don't have an exception in my consumer, it's acknowledged. But you can actually exert control over that if you want to in the low-level Spring Frame QP library. You can actually decide to not acknowledge a message and to have it redelivered, for example. There's knobs and levers that you can manipulate to get more more flexibility when you use RabbitMQ. But basically, it's a transactional message queue. When you send a message, it gets delivered to you, and it gets deleted from the broker. It's no longer there. Once you've consumed it, once you've taken responsibility and acknowledged receipt of that message, it's gone, right? You can't get it again unless you've explicitly re-queued it for redelivery. And that's good, but it means it's an ephemeral messaging system. Okay. Yeah. So, and there's some interesting nuance there around, okay, well, what if I have to redeliver it? Does it get written back or to the log or what? There's another style, another school of and oh, by the way, the other thing is that it does a lot of work. The other thing that it does a lot of work to keep messages in memory, right? The traditional assumption the holds that memory is faster than disk, which is it used to be very true, right? That's very, very true. So you have all this delicacy around, okay, I'm gonna take this message, but when I get the message, do I write it to the log? I want to make sure it's consistent, transactionality, all that kind of stuff. Do I acknowledge it and then write it, or do I write it and then acknowledge it? I mean, how long does that take? What about replication? If I'm doing replication to another broker, how long does that take? All that stuff is something you have to think about in the sort of more traditional style of messaging systems. Today, however, Apache Kafka has showed the world that you can do things a little differently. For example, Apache Kafka has an append-only log. Okay, append-only logs are it's a file system. It's a file, right? It's a file on the file system, and you're adding to it, so you don't have to seek. There's no updates. There's nothing like that. It's very efficient to append something to a file. In Kafka, I'm not sure about RabbitMQ, but I imagine it's the same. In Kafka, it's disk only. You're not dealing with synchronizing memory to disk and all that. It's always disk, and the assumption there is it's SSD. We're in the world of an era of SSD and high speed, disk access. So there's no point in introducing that fragility around synchronizing the state between the buffers on the disk and the buffers in memory, right? It's just go straight to memory always. Let that be your source of truth. And it's also durable. So you're not trying to clean things up. You're not trying to delete things later on, which means that if you want to, in theory, you could read the file from the very beginning, start from the very beginning, go all the way back to the latest message, and arrive at the same state. And we talk about that when we talk about event sourcing, right? That's a very common practice these days. Append-only logs change the paradigm, and they're also great for since they're on disk, since you're writing data, and since you can redeliver that data, you can just re-queue that data, just reread that data. It's also great for moving data around, right? Because the data is durable, and you don't have to. It's not like it's creating duplicates of the data, right? If I send, let's say I send a gigabyte of data to another node, okay, well, I'm not, if I have 5 different nodes that are going to be reading from that gigabyte of data, I don't have 5 gigs in memory. I just have 1 gig on the disk, and all 5 clients are getting the same, they're getting, offsets into that same file system. So it's not duplicating things in memory. It's much more efficient in that respect. So you can actually move large amounts of data, and you can do so very efficiently, right? So this is the idea behind, there's more optionality for certain kinds of use cases here, certain kinds of workloads. And Kafka has become a sort of a general purpose workhorse for data, the movement of data across the system, not just events, not just notifications of events, but like I want to move data from my Spark cluster, for example, right? How do I conduct gigs of data per second, right? And so RabbitMQ Streams brings RabbitMQ, it gives RabbitMQ the chance to do serve the same sort of use cases. And it's very, very, very fast. This is the other thing. Compared to traditional transactional RabbitMQ Streams are really, 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 really fast. We had Colin. Let me see. We had a guest on the show recently, Arnaud. I forget. I speak French and I don't remember the last name. We had him on the show recently, and he talked about what you might expect and the details of all that. And I couldn't begin to reproduce the depth and detail of his, description of the technology. But suffice it to say, super fast, right? Really, really, really fast and very efficient. So you can handle more clients at the same time, moving more data through the system at the same time, right? For each of those clients. It's just a overall very, very impressive situation to be in these days. So we're going to look at that next. But in order to do that, we've already got our first hiccup, which is it's not enabled by default. If you want to use RabbitMQ with RabbitMQ Streams, you need to enable the plugin in RabbitMQ. Okay. So what I did was, well, first of all, let's see. We'll go here. We're going to create a RabbitMQ Streams. Okay. We're going to use Spring integration. We're going to use RabbitMQ. We also have to add a dependency manually, and I don't like having to type things in build.gradle or pom.xml. I feel like I've failed if I can't just like Command B and hit Command Enter and be done with it. Okay, so Spring integration, Spring for RabbitMQ, hit generate. I think this works with Graalvm. I don't know. I haven't even tried it. Actually, that's a good point. We should try it. Let's see. RabbitMQ zips. Let me see. CD code this. RabbitMQ. So the code, I've already written the code. It's successfully stored here. Let me just make sure so I don't end up deleting the working thing. Okay, good. So that seems fine. Let's go back up here. Also, notice that I'm clumsy on my keyboard again because I've been away from this fairly new keyboard for a week for DevNexus, and my muscle memory is already starting to fade because I just don't have that much experience with this one. Take 2, UAO, RabbitMQ streams.zip. Okay, and so the first things first, we need a Docker Compose file. RabbitMQ streams Docker Compose to download RabbitMQ streams. Okay, good. So here's a Docker Compose file that thanks to Artem, he pointed me in the right direction for what was needed, was able to get working. So basically, there's a pivotal RabbitMQ streams Docker image that you can use, but this is the more generic default one that you'll find on the internet. So I just decided to make that one work. It doesn't have the plugin enabled by default. Maybe somebody is there a way to run like a post init thing in Docker Compose? I didn't even look, but basically you need to run a command once this thing is started up. Oops. Oh, yeah. Okay, so once this thing is started up, I'm passing in an environment variable that's new. I wasn't doing that in the basic RabbitMQ stuff. I'm also opening up this port. Okay, so there's 3 things that are different here. This, and when we run this, we're going to have to run a command in the Docker container to enable a plugin. Okay, so let's get that underway. So I'll go over here, cd RabbitMQ streams, Docker Compose up. Excuse me. override the command and or entry point to run on it. Can I do that in the Docker Compose file, or do I have to like create my own Docker? I don't want to do that. I mean, I'm sure there's a way. I'm just, my Docker foo is not very good. Okay, so Docker PS, right? Yeah. Okay. Oh, good. Okay. So there's that. Oh, but you're saying I'd have to like, if there's any logic to pull together the command dynamically, I'd have to like reproduce that or something. Okay, well, whatever. So okay, this is here. That's the Docker container. Let me see, history, rep Docker exec. Okay, there you go. So it's this one, Docker exec that RabbitMQ plugins enable RabbitMQ stream. Yeah, good. So that'll enable the stream here. I'm going to put this in a README. Okay. Okay. README on this first. Good. So run that. Okay. Good. Okay, add a volume. That's a good point. If I want to enable the plugin, maybe I could use a config file in Docker, a volume and a config file and a volume with a config file. Okay, yeah, that makes sense. I mean, you know, that's a great idea. That's a good idea. If you were watching a better live stream, that would have been something I would have done. But you got me. Okay, let's see here. Here we go. Opening this. Let's see. So we need to add the dependency. So let's go back to here. Subble downloads RabbitMQ. No. That's code. RabbitMQ streams. Okay. You have to have this custom dependency, and I wish this was on the Spring initializer, but it's not. So we'll just do it the old-fashioned way, painful though it is. Copy and paste this. Okay, voila. It is mercifully managed for us by the Spring Boot dependency management plugin, right? Which is configured for us here when we use IO Spring dependency management, or you have the same thing when you use the Maven plugin in Spring Boot. So I don't have to specify the version, but I do need to bring in org Spring Framework, AMQP, Spring Rabbit Stream. Okay, once that's there, now we have all the bits we need to actually write code against RabbitMQ streams. Okay, so let's see. First things first, we need to define what's called a stream, right? This append-only log has a logical name. We need to like care for that, right? So let's go here. Well, first of all, that's a good point. We need properties first. We're gonna connect to the RabbitMQ stream, and there's separate properties. Spring Boot auto configures this for you, but it's got separate properties than you would use for RabbitMQ. So Spring RabbitMQ password and username and so on. That's different, right? We're using Spring RabbitMQ stream username and password, which is nice. We're also connecting to a stream named this. It would be I would like it if it would define the stream for me. It does not. Also, if you're using Spring RabbitMQ to consume messages from a RabbitMQ stream, then you're overriding the type of message listener container that Spring Boot and Spring Integration and Spring for AMQP will automatically set up for you. You can only have one or the other by default. I mean, if you wanted to take things into your own hands and write your own machinery, you could do that. It wouldn't be fun, but you can definitely do that. So since that's why I'm doing this in a separate Java process, in a separate project, because I've already got the other ones using the default listener type. But here we need to say listener type equals stream, not direct, not simple. Container where the listener is invoked directly on the RabbitMQ consumer thread, thus blocking it. Don't do that. Or container where the RabbitMQ consumer dispatches messages to an invoker thread, or a container that uses RabbitMQ stream client. Okay, so that's the one that we're using here. What else do we want? What else do we need? Well, we need code. So go here. And we need to initialize our stream. And the way you do that is, unfortunately, there's no remember I showed you earlier, there's an AMQP admin that you can use to programmatically, via the protocol, basically. Via the protocol, you can programmatically create infrastructure, your exchanges and queues and whatever. Well, here you need to use the environment object. This is not the Spring Framework environment. It's a COM RabbitMQ stream environment. You need to inject that environment, which is auto-configured for you, and then do it as early as possible. I'm doing this in an initializing bean, which will be earlier than any application runners I have in the context. Call stream creator.stream, pass in the name of the stream, and remember that property is bound to this value here called stream requests. Okay, so I'm going to use that property. I'm going to use that name, stream requests. That's this bit right here, and I'm going to create a stream. I would like it if I could use something like RabbitAdmin to do this, or if I could have a bean of type stream or something. I mean, this feels a little different. It's very asymmetrical. With Spring and RabbitMQ for the basic stuff, I can just define beans, or I can use the AMQP admin. For this, I have to use the stream creator.stream.create builder, which is totally different in style and substance. So, it's fine, but just be aware. You got to do that, and you got to do it early, because if you do anything that depends on the stream, it needs to be ready by the time you do it. Okay, so let's just confirm that so far we've got something that'll actually run. Oh, and also I've got a RabbitMQ broker over here, right? So you can see I've got stream requests. I'm going to delete it because this is the old stuff. Delete the queue. Yeah, now I'll restart. Let's see if that worked now that I've deleted it. There it is. Good. So we've got stream requests. It's got nothing in it, so clearly that's worked. I was able to programmatically create the stream. It's running. It's ready to be used and consumed and all that. Remember, you got to have that port open as well. This is on a separate port. It's a plugin, right? These tend to be, RabbitMQ is very, it's not a monolith. It's a microkernel. Lots of little plugins doing interesting things in coordination with each other. Okay. Now comes the easy part, right? This part right here, getting to this point, took me 45 minutes because the documentation was better than what I would have done, but not quite enough so that I could get to where I needed to go. So I expect that I will be sending pull requests or something. Okay, so now we need the actual, what are we gonna do? We're gonna have a message channel, right? This message channel, we're just calling this stream message channel. Okay. And then we need something to actually send the message into that message channel to be delivered via the outbound Rabbit stream adapter. So we'll create a bean using application runner. So I'll say producer, return new application runner. And in order to send this message, just as before, we'll say this.stream send, and we'll have a message, a Spring Framework, a Spring integration message, right? That's also a Spring Framework message. So this gets confusing because we got RabbitMQ with its message and its message builder. So make sure you're using this one with payload. And we're going to say payload streams. And did I copy and paste that method? No, I didn't. So let's do that here. Static map string payload string name map.of message. Hello. All right. Good. There's that. All right. Good. Okay. I'm going to send the message. Yeah. And that's going to fail because it's not going anywhere. So at this point, I need an outbound adapter. And so we can create an integration flow to take messages from that message channel and send it off to RabbitMQ and to the RabbitMQ stream. So we'll say return integration flow dot from this dot stream message channel dot handle, and I'll say Rabbit stream dot outbound adapter. I'm going to inject the Rabbit stream template, which is a new thing as well, right? Rabbit stream template, another thing that's new in the newest releases. This is like a year old, all the stuff. RabbitMQ streams and the support and Spring integration is no more than a year old. So it's really very well thought out and well put together for something that's so new. I don't think I need anything else, do I? Channels, headers, I mean, yeah, it looks like it's fine, right? Okay, and then good. Okay, so it's going to send the message out via this template. This template is informed by the environment, and the environment is informed by the properties that are in the property file. So it's all connected, circle of life. Okay, good. Now, let's see if that works. I mean, it should start up and send a message. If everything has gone to plan, we'll see a message, 1 in the console there. Okay. There it is. Ready, 1. Total, 1. Okay, so we've got 1 message. Can we get the message? Bindings. Move messages. Well, yeah. Okay, so now we want to consume that message. So integration flow inbound integration flow dot from Rabbit stream inbound adapter, and here we're injecting the environment. Again, the COM RabbitMQ stream environment, not the Spring Framework environment. We want to hit handle payload headers. And then we want to just dump the results, right? So payload. What is that? New generic handler of type map of string. Right, that's the payload there we're sending. And the payload is up here, map string. So for var h headers dot key set h headers dot get h and payload. Running it, let's see what happens. A stream must be specified. Ah, yeah, okay. So configure container c.stream converter? No, that's not it. Configure consumer customizer. I don't remember doing this. There's something here for, is the outbound or the inbound? Okay, I'm going to cheat. I'm going to go look at my notes here because who wants to waste time? Okay, so on the inbound, it's here, right? RabbitMQ, configure container, blah, blah, blah. It's like this. Okay, so we do that. So on the inbound, we have RabbitMQ inbound adapter configure container. And then we just put that in there. That goes to this. And we need the pointer to the Rabbit properties. All right. Good. That looks like it'll work. Who knows? Let's find out. Ha, cool. So there you go. I literally blinked and it was already sent and received, right? So message, hello streams, AMQP expiration, blah, blah, blah. Okay. Not bad. That's awesome. That's like, basically the same as RabbitMQ. There's a little bit of extra ceremony around setting up the stream itself and consuming it. But basically, if you're using Spring integration, you don't have to worry about it. You're just thinking about inbound and outbound. You're thinking about messaging. There's also a gateway, which is kind of interesting. So we could have rewritten this to be more of a gateway example. So how would I do that? Let me think about this. Do we want to try that? Let's try it. Bean integration flow gateway turn integration flow dot from rabbit stream dot. Is there no gateway? Oh, I could have sworn there was a gateway. Outbound stream adapter. Oh well. Good. Doesn't matter. But there's no gateway. Doesn't matter then. Fine. Well, there you go. That's RabbitMQ streams, and it's awesome. And just definitely check out this Beautiful Podcast.fm. There's the latest episodes. 2023. Let's see here. It was January. Was it last year already? I could have sworn it was this year. It's it's already April. I don't know. I don't even know how the year got so far ahead of me. But okay, so let's see. All episodes 2022. Yeah, this gentleman right here. So November 9th of 2022. Listen to this episode. We weren't doing these. I didn't have a YouTube channel. Otherwise, you could have watched. It was a fun episode. But truly, like RabbitMQ streams. Let me see. RabbitMQ streams performance. Okay. Okay. Streams are persistent data structures that are designed to store large amounts of data with minimal in-memory overhead. Stream queues can be used with traditional AMQP O1. Oh, that's the other thing. You can use RabbitMQ streams directly from the AMQP protocol or directly from a proprietary protocol for RabbitMQ streams. It's open source. It's just not the AMQP spec, right? So I'm not sure what the inbound and outbound adapters for RabbitMQ streams are using behind the scenes here in Spring Innovation, but you can, if you want, use them from regular AMQP clients. From, if you've got an old Python Pika client using Python, in theory, you could just talk to the RabbitMQ stream from that same client without having to upgrade it or teach it about RabbitMQ streams. And so you might get some benefits from that too, right? Yeah, okay. So this is on our blog, okay? This is on the VMware blog. Remember, VMware and the Spring team and all that, we are the largest contributors to RabbitMQ, okay? This is not like a competing vendor trying to like disparage RabbitMQ or whatever. This is what we published about our own thing, right? The thing that we work on all the time is, hey, if I'm using regular quorum queues, I can do about 38,000 messages per second. If I'm using streams on AMQP, which is like the adapter layer I just told you about, I can do 48,000. So already, if you're just doing regular streams through the AMQP protocol, it's still 10,000. That's like 25% faster, right there. But if you're doing direct native streams with the stream protocol, using the stream API network protocol, you get 1 million. So yeah, what is that? Almost basically 20 times faster, right? 20 times faster than than what you get using AMQP or using the transactional queues. The quorum queues is what they're calling it here. 20 times faster, just using that. That's the reason you use RabbitMQ streams, right? Is you want that kind of performance, that kind of scalability. Wow. Okay, we set the number of streams 2 to get high throughput as the number grows. Okay, so so now you can increase. You can see it scales really well, right? I get 1 stream, I get 1 million per second. If I get 3 streams, I get almost 3 million per second. If I have 5 streams, I have just over 4 million. So it's not quite linear. It's degrading, but still, like 5 streams, and I'm doing 4.3 million per second. Wow, that's crazy. Actually, I didn't realize those numbers were so. I knew it was like I just said 10x, didn't I? I think I said 10x earlier in the stream, and that was me. Pretty sure that was correct. I remember it being some astronomical like increase, but the fact that it's like 20 times faster in this example is perfect. Let's see here. Performance sub-entry batching. Oh, hello, Salah. How are you? Welcome. Thanks for joining us today. Let's see. Performance sub-entry batching. 1 stream. What is this? What am I looking at here? Actually, I don't even understand what I'm looking at. So during the test, we set the number of messages placed in a sub-entry to increase throughput. A sub-entry is 1 slot in a publishing frame. Meaning the outbound messages are not only batched in publishing frames, but in sub-entries as well. I don't know what I just read, but it sounds cool. Performance, sub-entry batching. So if you do 5, I don't know. So it looks like I can do a thing. Okay, while on 3 streams with 1 kilobyte message size, which is 1,000 characters, that's a lot of JSON, right? Like, it's not the biggest, but it's a lot. It looks like if I have 3 streams with 1 kilobyte size, the average rate climbed to 500,000 messages, almost 500,000 messages per second, which is around 42 billion messages a day. If you kept it up at that velocity, which I hope you're not, but I hope you don't have a problem that needs 41 billion of anything, because that's a headache. But at least RabbitMQ won't be a part of that headache, right? There's just headaches everywhere in the stack at that scale. But it looks like RabbitMQ is ready. Okay, so I think that's a pretty good brief intro to RabbitMQ streams. RabbitMQ streams are supported in Spring for RabbitMQ. They're supported at higher levels in Spring integration. I didn't really even bother with Spring for RabbitMQ because, again, I like Spring integration. It gives me the best of breed sort of integrations while letting me focus on the overall messaging flow, right? I want to write messaging integration flows. I don't want to think about the nuances of this protocol or that, and I don't want to sacrifice anything either. So I get the best of both worlds here. This has been fun, but I got to go meet my friend, and it's been a long week, so I'm going to call it good for now. I appreciate you. I'm gonna, like I said, I'll probably talk to you all from. We'll talk. We'll do live streams from Utrecht or from Amsterdam and Paris and DevOps France and all that. So I'll see you all next week. Have a great one. Great weekend too. Appreciate you all. Bye-bye.